figure out, is a point inside the circle, is a point on the circle, or is it outside the circle? Okay, so now there's a long way, and the long way makes sense, right? Okay, and there's a short way, right, which is quicker. Okay, so I'm going to show you the long way to explain what we're doing, right? Okay, and then I'm going to show you the short way because there is really a quicker way. Okay, so if a point could be inside the circle, it could be outside the circle, or it could be on the circle. So inside, will I go on or outside? So you'll be given the equation of a circle, right? Okay, so you'll be given the equation of a circle, x squared plus y squared equals r squared. And you'll be given a point P. So point P. Right, so you'll have your circle, and you'll have P. P is somewhere inside the circle, okay? So it's somewhere inside the circle, right? Is that okay? And you have to figure out, you have to prove it without drawing it, okay? Right? So to prove it without drawing it, right, the length from the center, which is 0, 0, to the point P is less than the radius. So the distance formula that we were just using, you use it again. And you get the length from 0, 0, because that's the center, to P, right? And into the calculator, into the formula, into the calculator, get an answer, right? Okay, and it turns out to be less than the radius. The radius you can get from the equation.
Wait, what do you put into the calculator?
The distance formula. When you put 0, 0 and your point P into the distance formula. I'll do an example in a minute, just bear with me for a minute, right? You want to figure out, is it on the circle? Again, you're given the equation of the circle, okay, and you're given a point P again, right? Okay, so this time you want to prove that P is on the circle, right? So P is on the circle somewhere, okay? And you basically get the length of the line from 0, 0 to P.
Excuse me, please, Amy Mulcahy to reception with your journal.
And it turns out it's equal to R. So it's equal to the radius. So you get the distance using the distance formula from 0, 0 to whatever P is. And remember, they'll tell you what P is, right? Use the distance formula, get the length of the line, and then compare it to the radius, right? If it's less than the radius, it's inside the circle. If it's equal to the radius, it's on the circle. So what am I going to say about the last one? If it's greater than the radius, it's outside the circle. Okay, so the point P, so you'll be given a circle. No, I'll put P over here just for a change point. So if you get the length from 0, 0, which is the center of the circle, to P, and it turns out to be greater than the radius. So I'm going to do a couple of examples out the long way, and then I'm going to show you the short way, okay? Because the short way is very handy, right? Is that okay? But I want you to understand what you're doing. That's why we're doing it the long way, right? Okay, so example. is 3 minus 2 inside, outside, or on the circle. Okay, right. Before we start, write down the centre of that circle. What's the centre of that circle? 0, 0. What's the radius of that circle? Square root of 13. Okay, is that right? Okay, now we're going to get the distance from, so we're going to get the length of the line from 0, 0 to 3 minus 2. Okay, so you need your distance formula, which is x2 minus x1 2b squared plus y2 minus y1 2b squared. So we call this x1, y1, x2, y2, and fill in. So square root of x2, which is 3, take away x1, which is 0, 2b squared, plus y2 is minus 2, minus y1 is 0, 2b squared, into the calculator, press equals, right, so type it as you see it into the calculator, and you end up with the square root of 13, right? Tell me, is it the same as the radius? Is it bigger than the radius? What is it? Same as the radius. So length is same as radius, so it's on the circle. Radius. So 3 minus 2 is on the circle. Is that okay? Right, example 2. Right, is, let's see. Is point is, now let's see, 5 root 5 no, can I do a different sum because I want it to be different? Minus 3 1 inside, outside, or on, outside, or on x squared plus y squared equals 12. Okay, before I start, write down the centre of that circle. What's the centre of that circle? 0, 0. What's the radius of that circle? Square root of 12. Okay, is that right? If you put that into the calculator, it'll come out as 2 root 3. But don't worry about that, that's the exact same thing. Okay, right. You might want to turn it into a decimal just to compare. Actually, we'll leave it for the moment. Right, okay. So now I'm going to get the distance from the centre to the point minus 3 1. Because I want to compare it to the radius. So x1, y1, x2, y2. Write down your formula before you fill it in always, because if you try and fill it in at the same time and do it wrong, you'll get 0 marks. But if you write down the formula, then fill it in and do it wrong, you'll get a 10 marks. Do you all hear that? Right, okay, square root of x2 is minus 3 minus 0, all to be squared, plus y2, which is 1 minus 0, all to be squared, into the calculator with that, and that would be the square root of 10. Right? So, is square root of 10 smaller or bigger than the square root of 12? Yeah. So the square root of 10 is actually less than the square root of 12. So if the distance is less than the radius, what can I say? Inside, outside, or on? Inside. Right? It's inside. Because look, if you think about it, here's your circle. The distance to the edge is root 12, and you have a shorter line, so you've only got root 10, so it must be inside the circle somewhere. Agreed? Right. Okay? Right. Can I show you the shortcut? Alternative method.
Would you not then try to work it out then and do it on and outside? Or you do that one so?
No, just one sum. Right. Is it inside, outside, or on the circle? So you've 1 3/10 of getting it right if you guess it. Right? But we did it and we got it right. Right. Alternative method. Right. Shorter. Okay. So I'm going to go back and do example 1 again. So example 1, redone. Okay. So example 1 was, is 3 minus 2 inside, outside, or on the circle? Okay. Example 1 was that one. Is that okay? So here's my circle. Plus y squared equals 13. Here's my point, 3 minus 2. Right, the shortcut is you fill in for x and y. So everywhere I see an x, put in a 3. Everywhere I see a y, put in a minus 2. Yeah? So it would be 3 squared. Remember, this is the exact same sum, different way to do it. Plus minus 2 squared, and you're comparing it to 13. So you're going to compare the left side to the right side. And when you work out the left side, you get 13 equals 13. So it's equal, so that means it's on the circle. Way shorter, isn't it? So you just fill in for x and y. If you end up with the numbers equal, that's fine. It's on the circle. If the number on the left ends up smaller, it's inside the circle. And if the number on the left ends up bigger, it's outside the circle. Right? So example 2 redone. Right, so example 2 was x squared plus y squared equals 12. Right, and the point was it 3 minus 3, 1. Okay, so everywhere I see an x, I'm putting in a minus 3. Everywhere I see a y, I'm putting in a 1. So it's minus 3 2b squared plus 1 2b squared equals 12 into the calculator with that. You get 10 equals 12. Clearly 10 does not equal 12, but 10 is less than 12, right? So what's the story if it's less than? It's inside, right? And if the number on the left turned out to be bigger, it would be outside. So if the numbers turn out to be the same, it's on the circle. If the number on the left is smaller, it's inside the circle. And if the number on the left is bigger, it's outside the circle. Are we good with this? Right, okay, so I'll give you loads of these to do. Okay, so let's do page 360. So between now and tomorrow we'll do 1 to 6, because they're quite short. There's lots in that, but they're quite short and you've loads of time now. Right, okay, I'll put up the page in a minute.